but these numbers are negative exponents. And when you have a negative exponent, that means it's a decimal. So 10 to the negative 1 is equal to 0.1. 10 to the negative 2 is equal to 0.01. And 10 to the negative 3 is equal to 0.001, etc. So when you see 10 to the 14th, when you see a pH equal to 14, what you're really looking at is this, 10 to the negative 14, which means it's equal to 0.00004, 14 times. So it's very small. So the higher the pH, the lower the hydrogen ion concentration. So the less hydrogen ions, the less acidic. The more acidic, the smaller the number. As we discussed earlier on in the year, when you're looking at proteins, their shape is very important to their function, especially enzymes. If this is a substrate, what is a substrate? A substrate is what the enzyme acts on. The enzyme is what's doing the acting. Now remember that all an enzyme does is speed up a reaction. So there could be one or there could be two substrates. So you could have an enzyme that works on two things. And what it's going to do is going to bring them together. So when it's done, the enzyme could link them together. One example of an enzyme would be a ribosome. And what does a ribosome do? It creates proteins by connecting amino acids. So enzymes can connect things together, they can break them apart, but they speed up the reaction. They themselves are not involved in the reaction. You have seen ribosomes in action, in videos, in animations. We've drawn them. You've done transcription translation just recently again. So you should understand that an enzyme, just like the ribosome is not part of the protein, the enzyme is not part of the reaction. All it's doing is speeding up the reaction. How does it do that? By lowering the energy required to get the reaction done. You have what's called activation energy. This is the energy that's necessary to get a chemical reaction to occur. If you're going from A plus B, I don't know why you're not looking up here since you're the one who's asking all these questions. To lead A plus B to make AB, you need a certain amount of energy to do that. Whatever the chemical, your products, these are the reactants, and these are your products. You need a certain amount of energy to make that happen. All of you know that. You've all lit a match. The match doesn't just burn on its own. You have to strike it. You have to have a spark, right? That spark is the activation energy. So activation energy is required to get a chemical reaction to occur. An enzyme lowers that energy requirement and lowers the requirement. So the reaction happens faster and easier at lower temperatures. Are we clear? pH can impact how an enzyme works. So if an enzyme has a specific shape for a specific substrate, at 1 pH, when there's just a few hydrogen ions around, when there's a lot, when there's 10, 100, 200 times, I should say 10, 100, 1,000, 10,000, 100,000, the enzyme shape changes because the hydrogens bond to the protein, to the enzyme. When the hydrogen bonds to the enzyme, what you get is a shape, change in shape, so then it doesn't work any longer on those substrates. So an enzyme stops working. This is called a conformational change. If you change the pH, you can change it back to its original form. So if you have here at a high pH, it's a high pH, no, sorry, that's not high. A low pH, why do I say low pH? Because it's a high hydrogen ion concentration, low pH. In a high pH condition, under a high pH condition, low concentration hydrogen ions, the enzyme works fine. You reduce it, you make it acidic. This is acidic. This is basic. Under basic conditions, it works. Under acidic conditions, the enzyme no longer works. Here, pass them out, please. Or just give it to somebody to pass out. So under acidic conditions, the protein no longer works because the shape is changed. It doesn't work on the substrates. But by the way, that's just one possible factor. There's three factors that can impact shape of the enzyme and the function of the enzyme. pH is one. Temperature is another. Remember, we call that denaturing. Things that can denature an enzyme. pH can denature an enzyme. Temperature can denature it. If you increase the temperature beyond its reasonable, beyond its range, its operable range, temperature, pH, or salt concentration can also impact that enzyme. So it's important that these factors stay pretty consistent. They are pretty homeostatic. You want these to be, you want these to stay pretty constant, which is what your body does. Your body regulates salt with its kidneys, temperature by sweating or shivering, or gaining fat or losing fat, and pH it regulates through various chemical reactions. Your pH of your blood is constantly is around somewhere near 7, which is neutral. It's neither acidic or basic. If it was high, if it's closer to 14, it would be called basic. If it's too low, if it's closer to 0, it's called acidic. So anything under 7 is acidic, anything over 7 is basic, and 7 is neutral. Yeah? Yeah. We all got that? So that should help you get this done.